All right, I think we're live. This is so strange for me being in the studio.
In the flesh, he's not a hologram. He's not a hologram.
What if we had the effects in your hand right through?
Whoa.
Wow, yes, hello. So I'm John, this is Dan Roth. This is very exciting. Welcome to the ASP.NET Community Stand-Up. So I'm kind of thrown off. I don't really, normally I just
This is what it's like being on the other side. John, you're right here.
I'm right here.
In the room, all the cool stuff.
Today is a big day. We've got the ASP.NET Core 3.1 release.
.NET Core 3.1, all of it. ASP.NET Core,
LTS.
WinForms, WPF, it's all
thing.
In there. It has shipped today.
So that's big. And then we've got Blazor updates from you.
There's Blazor updates, yeah.
And also some crazy new stuff.
Yeah.
That might work.
Definitely on the more experimental side of things that we're working on with Blazor. We'll dabble in some of these experiments.
Very cool. So I want to get right to that. So I'm going to hop over to my, all right, let's see if I can do this right. We've got a bunch of community links. So hooray. All right. So starting off, congratulations to the Carter team on their 5.0 release. So Carter is pretty cool. It's a very kind of lightweight framework. It's built with thin extension methods. It's inspired by Sinatra style. So this routing style. And then they do have some other things, for instance, they've got Open API built in by default. So yeah, pretty cool. So very kind of lightweight, things are defined directly to your routes.
Isn't Carter what was it? There's the son of somebody who's
so it's all spelled out.
There's a genealogy involved in this framework. Nancy,
yes.
That's right. There was Nancy, and then Carter. Frank Sinatra had a daughter called Nancy, so that's where that came from. And then Sean Carter. So I took Carter. Okay,
it's all very complex.
Whoa. Yeah. Jay-Z declares he's the new Sinatra. His real name is Sean Carter, so Carter. That is deep.
Yes.
Profound.
So there you go.
We are getting a little complaint about some echo on the mic. I don't know if there's anything we can do about that. We can look technical for a minute, fiddle with some knobs, and maybe I'll turn this one a little bit away from you. How's that? Is that better?
Okay. It's okay though. All right. We'll try and be okay. All right. Moving on. So along with this kind of very lightweight style.
Who's this guy?
This is this guy, David Fowler.
Yeah.
So he has been looking at building, very light, so part of this was based on some of these things where they compare different styles of, I think this came from, what was it called? I don't know. It was something where it was showing a bunch of different languages doing similar things. And the C# one was pretty verbose. And he was like, hey, how can we get this smaller? So this is a look at doing that. This
is about winning with fewer lines of code.
Kind of, yeah.
Okay.
So the idea what he wanted to do is build everything on the primitives. This is all, built on top of, the ASP.NET Core stuff. It's not trying to be too magic there. So here he's, mapping a get. So this is an entire, returning hello world from a route. And then he's also got a ASP.NET Core controller. So, just looking at how to make it as lightweight as possible.
So ASP.NET Core put on a diet.
Yes, exactly.
Slim down. Not from a runtime perspective, I assume, because ASP.NET Core is already pretty lean.
It is.
In terms of its runtime behavior, but just in terms of the amount of ceremony you have to do to get an app up and going.
Right.
Yeah, okay.
So you don't need, the whole program and the startup and all that. It's really kind of making it as self-contained and lightweight. So I always love Dave's experiments.
Let's say in your mic.
My mic is
the problem. What number does your mic say?
I'm mic number 2.
Mic number 2. Okay.
All right, let's see what happens.
There's a mic.
So here's mic.
You can crank up your levels.
2. Am I too quiet or too loud?
They're saying that you think they think your mic is off.
They think I am off. Well, see, I see myself moving there.
Yeah, the numbers don't lie. We have it on the screen. All right. Well.
Yeah. I don't know. Hello there. Hello.
There's a motion to just continue on despite the sound issues.
Yeah, Todd likes it, so we're going with it. All right. Okay. I don't know. It's funny seeing people saying the exact opposite. One person's like, yeah, it totally works, and someone else is like, this is awful.
I think this has to do with the whole audio sensitivity thing. Some people, you have to have the best sound system at home. Every little nuance will drive certain people nuts. Whereas me, I like as long as I can hear it, I'm okay.
Yeah. Yep. All right. Let's keep going. Okay. So integration tests. So here George is writing about integration tests with ASP.NET Core API. So this is I've got kind of a pair of posts here. This is kind of more of an introductory level, and he's just talking about what is it and how to hook it up with XUnit. So explaining what it is, explaining the test class. And then here he's talking about going through and creating a test using Web Application Factory.
Nice. So, yeah, that's what I would use.
Yeah, there you go. So just kind of a basic, hello world style. So this pairs nicely with another post we've got from a frequent contributor, Andrew Locke. So Andrew is talking about some more advanced integration test stuff. So I like how they set each other up here. So here he's talking about updating your application to .NET Core 3. So this is a little more complex because you've got some changes going on due to the generic host infrastructure. So some things you've got to do. So Andrew, I'm not going to spend a whole lot of time here. I want to give you as much time as possible, but he does talk about the steps you need to do to update from a 2.x to a 3.0 project. So specific steps and explaining how he got through those.
For people doing just general migration work, there is also migration docs.
The docs,
on the website. There's a whole section on migrating, and we have always a topic about migrating from whatever the latest version is to the next version.
You're right.
So there's a 2.2 to 3.0 doc and a 3.0 to 3.1 doc that you can also reference.
And Andrew has been going through and referencing those, and then sometimes he'll dig into specific other kind of questions or like going deeper into things.
A little more detail.
You're right. Those are very helpful. So skipping way to the end, I'll just kind of summarize what he brings in here, talking about, some of the changes you need to make. Like, for instance, differences in constructors and stuff. I think this is something where if you're updating, like you said, you need to go through those migration steps. If you're just creating a new one, it's nice that it's as simple as this first post that I called out here.
Yeah.
So, all right, Mike Brind, he's a great blogger for a long time. Here he's talking about localization in ASP.NET Core Razor pages. This is a beginning of a series. So here he's talking about kind of the basic setup for localization, declaring the different cultures and stuff.
I can see he localized already his spelling of localization.
I know, right? That cracked me up. Localization, yep. So here's, talking about setting up like request culture and stuff like that. Now, this is the beginning of the series because when we jump down to the end, he's saying like, hey, you will see that we do localize some things, like for instance, days and months are automatically translated. However, they're not actually localizing static content. So that's the next in the series. So I like how he ends with a cliffhanger.
Part B, the sequel.
Yep. All right. So this is, speaking of series here, this is a series on creating a blog. And this is, creating a blog using ASP.NET Core, all the latest stuff. This one looking at Markdown. So I was hoping he'd use MarkDig, and sure enough, that's a really nice NuGet package for Markdown support. So here he kind of goes through and just, does the setup for converting the Markdown to HTML and showing how that works. So mostly pointing this out because I think it's cool that here he's beginning a series and building out the entire blog. So
nice.
Yep.
Or you could do .NET New Orchard Core.
There you could. Yeah, absolutely. And yeah.
But everyone's got to cut their teeth building their own blog, right?
I think in this case, the blog is like nobody wants to make a foo, like a foo project. It's like, this is a nice, example.
It exercises a lot of parts of the stack.
I do agree, though. I would recommend, like, that's a nice use case, but for a real application, Orchard Core, and we should get Sebastian back on.
We should. Orchard Core is like shaping up. It's ready for prime time.
Yep.
I think he had a good talk at .NET Conf. If you haven't checked it out, see what he said there.
Cool. He actually helped me recently. I was doing a Twitch stream, and he helped me with some of the stuff for doing a headless CMS. Backing an application.
Yeah. Orchard Core's got some good headless features.
Yeah. Cool. All right. So now we got some fun Blazor stuff. Yeah. So Aaron Powell busted out with a crazy thing here, implementing search using WebAssembly and Lucene.net.
I think he showed me this at Ignite. This was cool. Go ahead. I don't know.
Yeah. Well, so I actually this was something that Steve Sanderson pointed out, and I was like, wow, this is neat. I think if I remember right, he actually even includes, is this one where he includes some F#? If not, I think he was also like, I saw another tweet on something with that at one point. But yeah, so hooking up Lucene.
Where's the F#? Where's the F#?
Am I right? I might
somewhere in here.
Yeah. See, taskbuilder.fs.
Oh.
Look at that. So here he's doing some F#
with Blazor.
I don't know.
You can do that. It's all just .NET IL at the end of the day. That's crazy, so that's fine. Yeah. So if I remember this right, this is a static site. It's a Blazor WebAssembly app.
Okay.
But he uses Lucene.net to implement search functionality client side in the browser. I think he even when he first did it, he built the index in the
browser,
app, using the app. And then we talked to him a little bit about potentially pre-building that as like a build step. But still, having a static site with full search capabilities using Lucene.net was pretty cool idea.
Yeah. Wow. So long, in-depth post, very interesting. Grab your cup of coffee. Okay, Jonathan Carter, this is just kind of neat. As a web dev, this is a useful feature. So this is a browser preview extension for VS Code. And the thing he was pointing out here is it has support for VS Online, including live share. So you can, in your VS Code, you basically get a browser preview. And that works for stuff like if you're doing React Dev or whatever, and you can see your preview in the browser.
Okay.
So, yeah. All right. Another Blazor thing. I'd meant to group these together, and I got them out of order, apparently. Bradley Wells talking about Blazor, HTTP Client Factory, and Web API. Another series here. So here, this is the beginning of a series. Here he's got, the idea is this is a server-side Blazor application, and then he is using Identity Server and Web API on the back end. So his back end application is calling into that other application. So here he's talking about using HTTP Client Factory to do that. So, yeah.
Very nice.
Yep. All right. I'm kind of rushing a bit because I want to make sure I give you enough time. Yes, I think I already showed that. Okay, cool. So Chris Sainty talking about custom input components for Blazor using input base. So this is something that I actually, I was talking to you beforehand.
Yeah.
This was something that had changed. I'm not even sure when exactly this changed. It was one of those things where it's like, yeah, I know Blazor. And then I started looking at something. I was like, oh, I'm a little out of date here on some of the stuff. So you have support in the box in an edit form for input text, text area, input select. But then if you want to create your own input components, you can use that base to do that.
Yeah.
So and here he talks about if you've got things like a real world problem of having kind of verbose controls and control groups, you can make something that, for instance, custom input component to group things together.
Yeah, and then have it plug into the validation system that those components provide.
Yeah. So then the whole form kind of works together. And I think that's a neat example of the components, doing more than just kind of simple HTML. It really starts to build up a more advanced system.
Yep.
So speaking of advanced components, this was when you just pointed out to me. You tweeted it, and I'd forgotten to include it in the link. So
more components.
There it is. My goodness, talking about the Infragistics components. So this is the Ignite UI for Blazor Preview. So yeah.
Brian's on the call. Hi, Brian.
Wow, hello, Brian.
Yeah. Yay. Infragistics has some Blazor UI components to try out.
Looking love pretty this nice. Too, seeing charts, advanced live grid and stuff. So I think this is really neat to see once you provide a really nice component model, then seeing, this support for vendors building the real thing, so I can build my own components. That's neat. Or I can shell out a few bucks and use these advanced components. So
we're using the good work from people that know UI better than me.
Yes, well done. Okay, and so I'm going to end up with this. And so this is the ASP.NET Core update 3.1. Yeah. So I don't know. You've also got this on your screen. So I don't know if we want to just pop over to you.
Yeah, we can pop over. And I
right.
see someone's asking about the Infragistics components to see if there's a free trial. And I believe the answer is yes. Like last I checked, the Infragistics package is just out there on NuGet. You can download it and try it out as a free preview trial. Brian, feel free to correct me if I've misspoken, but free.
Yeah. Cool.
All right. Yeah, so today we shipped .NET Core 3.1.
Congrats.
And this was honestly a short release. Like we just shipped 3.0. Like
September 23rd.
Not that long ago, we were in these rooms doing .NET Conf and sharing all the cool stuff that's in 3.0, WPF, WinForms, gRPC, all that stuff. .NET Core 3.1 is basically mostly just bug fixes. Yeah. We did squeeze in a few feature enhancements into there, including some Blazor stuff that we'll talk about today.
And part of the idea is that it was supposed to not change a lot, right? Because we wanted 3.0 to be like, this is the big release, and then 3.1 is the LTS release, which is, maybe some small like bug fixes and stuff, but really like
no breaking changes of any significant sort. It should be a very easy upgrade from 3.0 to 3.1.
Cool.
And the beautiful thing about 3.1 is it has a long-term support policy associated with it. So it'll be supported for 3 years. So if you're looking for something nice and stable that you can build on for years to come, .NET Core 3.1 is where you should go.
So the advice I've been giving people that have been asking me, like, now is the time, now should I get on? So what I've been telling people is, up till today, I said, go ahead and get on 3.0 because the update to 3.1 will be pretty easy.
Yep.
And then, but now, like, definitely get on 3.1 because, like, this is the LTS version. It's got all the cool new features. And the next release is basically 5, right? I mean,
the next release that's planned is .NET 5.
Yeah, which is a little ways off.
Yeah, that's scheduled for November of next year.
Okay.
And then that's when we start snapping to that yearly cadence that Scott Hunter talked about, where we will ship a major update to .NET. .NET Core, .NET, it's called kind of just becomes .NET with .NET 5, starting with November of next year. .NET 5 will be a current release, which means it will be supported, I think it's a 3-month window after the next major release.
Okay.
And then even numbered releases like 6.0, which would happen a year after .NET 5, 8.0 and so forth, those will be LTS releases. Okay. So that's the plan. I think the nice thing about this plan is it gives you real predictability.
Let me try and say that to make sure I caught it right. So 5.0 is supported until 3 months after 6.0 ships.
I think that's correct. Yes, it's a current release is what they call it. If you look at the .NET support policy, it talks about current releases and LTS releases. If you're looking for something that's that you can just build on and have it not move very much and it's going to be supported for a long time without you having to upgrade to the next version, then LTS releases are what you want to be on. If you're looking to just always be on the edge, like being on the new release, and you're okay with dealing with some level of churn from release to release, you're okay with having to upgrade to the next version as soon as it comes out, then you want to be on the current release. And 5.0 will be a current release.
Got it. Okay, cool.
Okay, yeah, so 3.1 just shipped.
Do you want me to share your screen?
I think we can do that. And there's a bunch of some new Blazor improvements that we've managed to squeeze in there into 3.1. Not a lot, but there's a few things. So I've already installed the bits. If you haven't installed .NET Core 3.1 yet, super easy. You're going to want to head over to .NET and go ahead and click on download, and the 3.1 download should already be right there. You can go ahead and install it. If you go look at all the downloads, you'll see there's .NET Core 3.1, and it is in fact listed as an LTS release. If you're using Visual Studio, like I am, I'm on a Windows machine, the latest update to Visual Studio 16.4, which also shipped today, that includes .NET Core 3.1. So if you've got the latest update, 16.4, then you've already got 3.1 on your machine, and you can always check that by just dropping down to the command line and typing .NET version, and that should read 3.1.100. That's the correct version for the 3.1 release. Okay, so I've already installed the bits. If you're on a Mac, you can get Visual Studio for Mac 8.4 is the sort of corresponding release on a Mac. It's still, I believe, in the preview channel, so you'll have to go to the VS for Mac preview channel to get it, but that also carries 3.1 with it, and so if you have that, then presumably you also have the latest 3.1 bits as well.
Cool.
All right, let's look at some of the new things for Blazor apps. So I'm going to create a new project, and I'm going to select create a Blazor application. This is my 8th Blazor app today, apparently. I'm going to go ahead and create a Blazor server app. Blazor WebAssembly is also updated today. We shipped a preview update to Blazor WebAssembly. It carries a 3.1 version number, but it's a preview version number. I think it's preview 4. It is not part of the broader .NET Core 3.1 release. So you should not expect that you now have an LTS version of Blazor WebAssembly. We have not shipped a stable release of Blazor WebAssembly yet. That's scheduled for mid next year. We're shooting for the May timeframe of 2020. So expect more preview updates for Blazor WebAssembly. You won't see it by default if all you did was install Visual Studio and .NET Core 3.1. If you want the Blazor WebAssembly bits, you have to run a one-line command to get the templates, and then they'll pop up and show.
So how does that work with the whole LTS version number, all that kind of stuff with Blazor?
The LTS version number applies to .NET Core. Okay. And Blazor WebAssembly is a separate package. It's a package you install separately. It's not part of the .NET Core deliverable, so it's not part of that LTS support lifecycle. Okay. Eventually, we will move it in there, and eventually we'll have an LTS support policy. That'll probably be a little while yet, and we'd like to ship a first version and give it some time before we actually say, yeah, okay, we're ready to call this an LTS. So I would expect that the first version of Blazor will actually be a current release. Okay. Meaning that when .NET 5 rolls around, we'll probably expect that you need to upgrade to Blazor WebAssembly and .NET 5 to continue to stay in support. But eventually later, maybe .NET 6 timeframe, that's when we'll probably have our first Blazor WebAssembly LTS release. Cool. That's the current thinking anyway. Okay, so let's go ahead and work with the stuff though that is LTS, which is Blazor server support. So I'm going to create a Blazor server app. This is what you can deploy into production today and get a 3-year support policy. So things that are new. First thing I wanted to call out is support for partial classes. So when you have a component, components, remember, are just classes. So I have a counter component here in the app. Let me make this a little bigger so people can see. There we go. And can I zoom? No, let me get some zoom going. There we go. Okay, so we have counter.razor, and when we build the app, that Razor file is going to get turned into some C#, turned into a .NET class and compiled. And then you just use it as a .NET class that knows how to render the stuff that you're seeing in your markup. In the past, if you wanted to separate out this block of code here, like some people like to keep their markup and their sort of code logic in separate files, like having a code behind file instead of having it all in one file. We think both patterns are perfectly valid, but some people really prefer the code behind file. If you wanted to do that before, you could do it. And the way you had to do it was you added a class. So I'm going to create a counter.razor.cs, and that'll make it nest nicely under counter.razor. And then before, you had to make this derive from, make this a base class basically, and have it derive from component base. And then you could then move the logic in, but you had to change the access rules for the members, because right now they're private. I have to make them protected because I'm going to make basically this counter base a base class of my counter component, and then you would do a thing up here that's like at inherits, and you would derive from counter base. And that worked. You could do that, but it involves more changes than maybe you'd like. We now have support for partial classes where you can define that code behind file, that separate where you put all your code logic as a partial class. So all I'm going to do, instead of defining a base class that I derive from, is I'm just going to add partial right here. And I'm going to leave the class called counter, because that's the name of the class that will be generated from my counter.razor file. Just going to save that, go back to my counter.razor file, and just copy this code as is, unchanged, put it in here, and save it. Now, if I go back to counter.razor, IntelliSense looks like it's still working. It still knows about the current count field and all that good stuff. If I run the application, it should still function, and we should have a working counter. Let's see, get this building. There we go. And if we go to the counter tab, I can click the button and the count does in fact go up. So nice. That's partial class support in Blazor. That works with Blazor Server and Blazor WebAssembly. We can see the sort of the mechanics of that if we poke into the project a little bit more and look at the generated files from those .razor files. If I go into the OBJ folder and dig down into this .razor folder, Here's the actual generated C# code for that counter.razor file. And if we scroll down past all the using statements down here below, you can see public partial class counter is what we're actually generating.
So Brian Lagunas asks, can he have a code block and a partial class?
Yes, absolutely. Like the partial classes, what you put in the code block will appear in this class, and then the partial class will get merged with that basically by the C# compiler.
Cool.
Yep, normal C# rules apply. Okay, so that's partial classes. Other things that are new, if we look in the host CSHTML file, so this is just a Razor page, right? This is like the bootstrapping page of the app. It's what's going to render the initial batch of HTML down to the browser, which then has if we look at the bottom, that script tag, which has the Blazor JavaScript, which sets up the connection back to the server. So we have that real-time pipe that we can then use for managing the UI. This is what's handling that initial render. Everything else is then done with components, and all the components are put right here. Now, before in 3.0, if you wanted to add a component to like an MVC view or to a Razor page, which you can totally do, you had a way to do that, and that was using an HTML helper. So it looked something like this. It was like you had a C# expression because it was an async call, so you had to await an HTML helper, and it was render component async. And you passed in a generic parameter, which was the component you wanted to render. Like, let's say I wanted to put a counter right here. And then you had to specify which render mode you wanted to render. And this is a little bit of an advanced concept. What is the render mode? When the component gets rendered initially on the server, there's 3 different ways that Blazor can do that. First is server. Server means just put a marker in the original HTML, and then when it gets down to the browser, and after you set up the connection, that's where I want the component to actually be rendered after you get the first diff batch from the server. Okay. Static means please render this component actually on the server and put its HTML right into the HTML output, and then that's it. Like don't bother with interactivity. Don't bother with you don't even need the connection at that point. It's just basically a way to put a static chunk of HTML into a page, kind of like a better partial. You could think of it that way. Yep. And then server pre-rendered is do both. Like it's like please pre-render the component on the server, but also then later wire it up for interactivity.
That seems like the best.
That is the best. Okay. Well, I mean they all have their scenarios, but in most of the time you're going to be doing server pre-rendered.
That's a lot of C# in my Razor. That's not beautiful code.
This line here we decided was a little bit harsh on the ice. So that's why we invented this component tag helper. This just packages up that line of code in a simpler way. You specify the type of the component that you want to use. You specify your render mode just as an attribute, and then you're good to go.
Question there. I mean, while we're talking about beautifying code, that type of app, is there a reason, since it's a string anyway, is there a reason to make a type of app as opposed to?
You'll notice that it's not actually technically from the Razor parser view a string. Like it's got that gray background to it. It's actually C#. Okay. So to put a string there, we could do some funny stuff with the compiler, or maybe have some sort of converter logic. Like really what that value in between the quotes is saying is take the type property of the component tag helper and set it to whatever's inside these 2 quotes. And so it is actually a .NET value that we're setting there. That's why it's type of instead of just saying app. But maybe there's something we can do there to make it simpler. You're not the first person who said that. I've felt that way. Like, why can't I just say? Oh, I'm still in zoomed in. Why can't I just say that? Like that's the question. And it almost looks like it would work, but it doesn't actually work. So you do have to say type of currently. So for example, if I want to put a counter right here, whoops. I have to actually put type of counter. We can do that, render mode, and I'm going to put server pre-rendered. For enums, we do that nice stringifying thing. Okay, so what I would expect to happen here then is at the top of the rendered page, I should see just a standalone counter component. And then below that should be the rest of the app, like the left nav and the home page and the counter page and the fetch data page should all appear kind of like as a big block below this counter that's sort of hanging out at the top. Okay. Let's see if that's actually doing what we expect. Yep, and so we have our weird counter sort of sitting here at the top. We just use a random component on our Razor page or MVC view, and then we have the rest of the actual Blazor app below. So that's how you can use the component tag helper to just add components wherever you'd like from within your CSHTML files.
So question from Michael on YouTube, he's saying that's just syntactic sugar, basically.
Right? They are functionally equivalent. It's just a nicer syntax than having to deal with expressions and await and async and all that type of stuff.
Cool.
So another thing that's nice now is previously we didn't support passing in parameters to these top level root components in your app. Like if I wanted to pass a parameter to this counter, in 3.0 there wasn't a way to do that. There is a way to do that now. So let's first define a parameter on our counter. I'm going to get rid of this current count field and just replace it with a property. I'm going to call it current count. And to make it a parameter, I'm going to attribute it with parameter. So this is now something a piece of data I can pass into the component to like initialize it. And then instead of lowercase current count, I'm going to do uppercase current count. And then I think in the markup, I also have to change it here. See it knows about the partial class. Making that tooling work was why doing that feature took a little longer. Yeah. Making the tooling work nice, so it was not easy. Okay, so now we have a counter that I should be able to pass in a parameter, and you can do that with both the HTML helper and the component tag helper. With the component tag helper, the way you do it is you do param and then the name of the parameter that you want to specify. So if I want to do current count, then I can do that right here. And I don't want the current count to be H. I'd like it to be 10. So that's how you can pass parameters into your root level components of your application. So if I save this, I think I should just be able to refresh, or do I have to rebuild? I don't remember. Oh, nope. So now notice that the current count is now initially 10. Like I pass in some data to initialize that counter from the beginning.
Okay.
So that's an easy way now to initialize your components with component parameters. Oh, what else did I want to say? So I've got so many things. I have to remember all the demos. So we did component tag pass. Okay, so prevent default. A common scenario with web development is you have some sort of event that's occurred, and you wanted to prevent the default action for that event. Like maybe you're typing into a text box. The default action would be to actually show the text that you're typing in that text box. Maybe you don't want that to happen for some reason, and so you prevent the default action.
I think I've seen that too sometimes on like a button on a form, and you're like, I want to handle the button submit.
Yeah.
Like, don't you do? So you want to prevent the default action for that form.
Exactly. And in Blazor, there are cases where we kind of do that for you, like with anchor tags. Like most of the time, we're intercepting the navigation and doing client-side navigation. So we're in some sense preventing the default navigation for you under the covers. With forms, if you're using our edit form, we have a whole model there for giving you an event that you wire up when you actually submit the form. So we're doing a thing there as well. But sometimes you want to write your own components that also prevent default. And that meant diving into JavaScript. And we all know that Blazor is about writing at least less JavaScript, if not no JavaScript. So we have a way now of doing prevent default. And so I'm going to add a new component here. Let's do a razor component, and we'll call this one, it's going to be a kind of counter. We've already got a counter though, so I'll call it counter2. And I have some markup that I'm just going to grab, and then we'll take a look at it. Okay, so here's our new counter. And the idea here is you have a text box, and it's just a number, and you want it to either go, the number to either increment or decrement based on whether you press plus or minus.
Okay.
But if you type in like ABC, you don't want ABC to appear in your text box. You want it to just show, the next number or the previous number in the list. So you can see we have just a little bit of text at the top telling you how to use this lovely component. We have our input and what the value of the count that we want to show up in that input. Whenever the user presses a key, we wire up a key press handler so that we can say that if the plus key was pressed, then increment the count. If the minus key was pressed, then decrement the count. But we don't want like plus to show up in the text box.
Right. You want to handle that and do stuff, but you don't want it to show up. Yep.
So we needed to prevent the default action. This is the syntax for prevent default. You specify the event that you want to prevent default for, and then colon, and then just say prevent default. This can also optionally take a value, like you could say like true, like please prevent the default, or if you had like some Boolean expression, C# expression that you wanted to put in there to say conditionally prevent the default depending on this calculation, you can do that as well. But the simple form also works. So if we need to use our counter2, let's put it on the home page. There it is. So we should have a counter2 now on the home page of our app. Let's refresh. All right, cool. And we go to the home page. Okay, so here it is. And so if I hit the minus key, it goes negative. I hit the plus key, it goes up. And I hit ABCD, nothing else is showing up on the screen because we're preventing that default action. So that's prevent default. A very similar scenario is, or kind of related scenario is controlling how events bubble or propagate. Like sometimes you want events that normally would propagate, you want them to do that, and sometimes you don't. Like sometimes you want to stop the propagation of an event before it goes up to other DOM elements.
Again, I've dealt with that in forms a lot, right?
Yep.
Something in a form, and you're like, I don't want the whole form to submit just because I hit enter inside a text field inside a,
Yep, exactly. So here's an example of that. I'm going to just copy over all of this. Well, this is a little bit more involved, but what we've got here fundamentally is just two divs, right? We've got an inner div and then an outer div, and then we have click handlers that we put on both of them. And normally, when I click, the event would propagate up to the outer div if I click on the inner div. But we have a checkbox up at the top that, depending on whether I check the checkbox or not, it will control the propagation. Here's where we're stopping the propagation. So again, very similar syntax: the name of the event, and then a colon, and you just say stop propagation. If you didn't put any value, it would stop it by default. If you have an expression in here, then it will evaluate the expression and stop accordingly. And then below, we're just printing out whether the corresponding div actually saw the click event or not. And we're just displaying that as like a list of messages. So if we save this and go back, let's go to the home page. Okay, let me get rid of that counter at the top. It's really kind of distracting to have that guy sitting up there. There we go. Let's save, refresh. Okay, so here's our parent div, and the child div's got the dotted line around it. So if I click on the child div, you can see that child div got clicked, and then that also propagated up to the parent div. If I click on the parent div, I only see the parent div got clicked. Okay, let's clear that. Now if we stop propagation and I click on the child div, only child div gets triggered, and parent div only gets triggered now at the top. So that's having control over event propagation in your applications. Hopefully that will enable you to build even more powerful components. The last thing that I wanted to show, I think is the last thing. Is this the last thing? Yeah, last thing from 3.1 is a better error handling experience for Blazor server applications. In 3.0, if you had some exception that happened on the server, often what would happen is that the app would just stop functioning, and you as a developer during the development phase would have no clue why. You'd be like, why am I getting a blank screen? Or why is this thing just not doing anything anymore? And if you actually looked in the console of the DevTools, you would find out, oh, some error happened, and then you go check the logs on the server to find out what the exception actually was, and then you figure out what's going wrong. But a lot of people beat their head against the wall for hours trying to figure out, why is my app not doing anything? So we decided we wanted to make that a little bit better. So we just made a very simple change. I'm going to add a exception just right here in my original counter component. So throw a new invalid operation exception. Boom.
I like to do that. Just put them in there.
For fun. You go to random GitHub projects and it's like, I'm just going to add a pull request here. Okay. And then if we go back to the app and refresh, and if I click on this counter, you see I now get this yellow bar at the bottom. And this is telling me, hey, an unhandled exception has actually occurred. Let me make it a little bigger.
Does that show to everybody, or is it just like in development?
So it's conditional. It's conditional.
Right.
We'll look at how it's implemented. It's actually completely under your control.
I spoiled things for you.
What this thing? No, that's a great question. So if I go look in the console, like the DevTools console, like it asked me to do, I can see the exception right there. That I had an invalid operation exception. Go fix the bug, and then you're good to go. Now, where does this come from? If we go look in that host CSHTML file again, you can see it's just some Razor markup that's happening here. If the environment is staging or production, we show a little bit of UI to just let the user know, hey, 500, go contact your admin, and you can do whatever you want here. If you're in development, that's when we show a little bit more to say, you might want to check the browser dev tools to see what's going on. This ID here for this div, when there is an unhandled exception, the Blazor server framework will toggle whether this div is hidden or visible. By default, the styles hide it, and then Blazor server will show it. So you can put whatever UI here you'd like, or just not have it at all if you don't want it there. It's purely template code with a little bit of framework infrastructure.
Okay, now that you mentioned that, there was a recent tweet or something I saw where somebody was looking at the Blazor server JS, and there's extra like settings and stuff you can call in there that they're like parameters you can pass to that. And they're like, oh, if you want to change, I don't know what it was, timeouts or whatever, you can do that.
Yes.
Which is kind of interesting.
The JavaScript libraries for Blazor do have a corresponding set of APIs that you can fiddle with, like if you need to mess with some of the SignalR settings that are being used under the covers for the SignalR client.
So you shouldn't have to, but it's nice that they're available.
Sometimes you need to, and that's why they're there. Yeah, cool. And so you can check those out and learn how to use
Blazor
those.
options, and I think it was Blazor Mr. Magoo that tweeted it. So there you go.
Mr. Magoo, how you doing? All right. Okay, I think that's all the new stuff in 3.1. The next set of stuff I wanted to show was what's new in the Blazor WebAssembly release that we just pushed out. Remember, this is not part of 3.1. It's not part of the LTS release. It's just another preview of Blazor WebAssembly, and we're going to continue to work on that towards the final Blazor WebAssembly release, which is scheduled for May of next year. So I've already gone to Blazor.net, Blazor.net, and went to get started, and I installed the latest preview 4 template, which hopefully this has been updated. Yeah. So this is how you get the preview 4 version of the Blazor WebAssembly template that corresponds with the 3.1 release that we just pushed out. And you do need .NET Core 3.1 to use this. Once you've run that one-liner, you should now be able to do File New Project and create a Blazor WebAssembly app. And that was that second template that we saw in this UI here. For folks on the call, a little tip. I have seen sometimes that after I install it, that it doesn't show up here initially unless I click away from 3.1 and go back to 3.1. I've seen that happen once. Maybe a bug. There may be a bug here. Right. So if you don't see your Blazor WebAssembly app template after doing that, then try just fiddling with the version real quick and see if it shows up for you. Okay, so let's create a Blazor WebAssembly app. What's new in this release? By the way, our attention now is almost completely now moving to focus on Blazor WebAssembly, at least the Blazor team. We were shipping Blazor Server. We've polished that up with 3.1. Now our focus is getting Blazor WebAssembly out the door. So you should expect to see a little bit more momentum, a little more faster progress as we move towards that release. So things that we enabled in this release, if we look at the project file, you'll notice that the template now targets .NET Standard 2.1. Previously, these templates were targeting 2.0, which prohibited you from using 2.1 libraries if you wanted to in your Blazor WebAssembly apps. You can now use 2.1 libraries in your Blazor WebAssembly apps.
Are there any big blocker things? I mean, I forget now what was huge in .NET Standard 2.1.
Things that are 2.1
I'm just
only.
Curious if there is any real forcing things where people are like, oh, I really needed it.
I'm sure there is. I'm sure there's great stuff in there. And off the top of my head, I can't think of it. But at least now you have that full capability. We now support 2.1. Of course, within the limits of the browser security sandbox. If there's a new API in 2.1 that helps you do something with, I don't know, Windows Forms or the registry or whatever, the stuff that won't inherently work in a browser, obviously that functionality won't work and you'll get some sort of platform not supported exception. Cool. But this is now available. We're pretty sure we fixed the issues with iOS 13. If you're trying to work on an Apple device, you should be able to get Blazor WebAssembly apps to function there now. We had some issues where they were being really restrictive with the stack size, and the interpreter that we use to run these apps had sort of a recursive implementation. We've switched that up to be non-recursive, sort of stack size isn't as large, and it now avoids that issue. So iOS 13 should now be functional.
I had a question recently on where's the best place to see browser support for Blazor? Is it just in the docs? Where's?
We do have a browser support matrix in the Blazor docs. Okay. It's a little different than you might expect, and it might be good to get feedback from people on this. Honestly, if we, I'll show it actually. This is kind of breaking into jail. We might raise some eyebrows from folks. High level. Our intention is, of course, to support you. We're going to support you. With Blazor WebAssembly, the big, obviously we can't support IE 11 with Blazor WebAssembly because IE doesn't support WebAssembly. But where is it here? Browser support. Hosting models get started. Supported platforms. Okay. Now you'll notice that we support all these browsers as long as you're on the current version.
Okay.
That's the story. So, and this reflects how we test currently. When we test our Blazor applications, we're testing against whatever the latest version of the browser is that we've snapped in our build systems. Now, I know I've talked to some people who find this a bit dissatisfying Like they are like, I'm in some enterprise, I'm stuck on some other version of the browser, and you're telling me I'm not supported. That's not really the intent. We of course want to support those types of scenarios as well. We probably have some work to do to better communicate, like, well, this is the version of the browser that we know we've tested with, and we kind of snapshot that version and document that here. Blazor does work on older versions of the browser other than like, the current.
Right.
But at least right now, this is what's been documented for our support policy. So let us know what you think about this. If you need us to go back to some particular version of a browser, we'd love to hear that. If that version is IE 10, sorry, that's not going to happen. But we do want to have a reasonable support matrix here so that people feel well supported. Debugging. So one of the big deliverables for Blazor WebAssembly before we ship it is we want to have a good debugging experience. Now we've been working on a debugging experience for Blazor WebAssembly for a while. It was one of those things that when we started this whole project, people were like, "Can you even debug C# when it's running in a browser? How is that possible?"
The right command line options to
maybe.
When you start.
So right now we have the in-browser debugging experience that we've shipped for a while. And if you go into the dev tools, you'll see there's this debugging hotkey, Shift-Alt-D, that you press. And if you press that, what happens here is it pops up the browser dev tools and it points it at that tab that I want to debug, basically in a remote debugging style configuration. But it actually inserts in between those two guys a proxy, a debugging proxy that we provide. And that debugging proxy speaks the JavaScript debugging protocol of the browser, but also augments it with a bunch of .NET specific stuff. Yep. And that's the magic. That's the really cool stuff that makes this all work.
Who had to write that?
.NET people that are smarter than me. But in order for that flow to even happen, the browser has to be running with remote debugging enabled. So that's what this tab is telling me, is that, hey, you didn't actually start the browser with remote debugging enabled, so I can't actually do that connection. Please start it that way. So it gives me the command to do that. So I'm going to run that command. And just for cleanliness, I'll close up the older tabs. So this restarted the browser, but now with remote debugging enabled, if I hit Shift-Alt-D again, that little debugging hotkey, I should get the browser dev tools popping up. And if all goes well, we should see some stuff show up here in the left-hand side. Okay, so if we poke around, oddly enough, there's like C# files in here and Razor files in here, and you can set breakpoints and hit them in the browser, all this type of things. You can see local variables, and that's pretty impressive what the .NET Runtime folks have been able to achieve. Okay, that's the in-browser experience, and it's been there for a bit. It has a certain level of functionality. There's more features that we want to enable here to make it as high fidelity a .NET debugging experience as we can. But of course, for most .NET developers, what they really want is just to hit F5. Yep. They want to debug from Visual Studio, which is where they've always debugged their .NET applications. Yes. So we've started work now on connecting the dots between Visual Studio and your Blazor WebAssembly app so you can debug in the IDE. Now, the good news is Visual Studio knows how to speak the browser debugging protocol. So the trick is to get Visual Studio to talk to the browser tab that you want to debug through the debugging proxy, and then have everything kind of get mapped correctly in the editor.
So I still need to do that thing where I launch the browser with the right variable, with the right like command line thing, right?
You still need the browser to launch with remote debugging enabled. Okay. Now, Visual Studio actually also already knows how to do that too. Because when you debug JavaScript in Visual Studio,
it pops up a browser.
It pops up a browser, and it pops it up with remote debugging enabled so that it can attach to it, so you can hit breakpoints in your JavaScript from within VS. So that's basically the infrastructure that we're going to be leveraging to get F5 to work. And it requires that the debug proxy to speak certain parts of the protocol so that Visual Studio knows how to attach. Now, that whole experience is not available with this release, but some parts of it are, so that you can now at least try out attaching Visual Studio to the browser. Okay, so I have the browser up. Now, to get this to work, I actually need to do this over not HTTPS. That's a limitation right now that will be addressed in a future update. For now, you have to do it over HTTP. So I'm just going to go into my app's debug settings and grab the HTTP address for this app. It's listing on both HTTP and HTTPS. And I'm going to browse to HTTP. Okay. So now we have a browser with remote debugging. I already enabled it because we just saw that. And it's set up at an HTTP address. And then in Visual Studio, I'm going to do debug and not build, debug and attach to process there. And here's what you got to do. These steps are not what you will have to do in the fullness of time. You'll be able to just hit F5. But if you want to try it out today, you select Chrome DevTools Protocol WebSockets, no auth. That's basically telling VS attach using the Chrome style debugging protocol.
Yep.
The target is that HTTP address that I hit before. Now, do not hit this find button. Like, bad stuff will happen if you hit this find button. All you want to do is hit enter, which is not going to hit that find button, which surprises a lot of people. And then there's my tab that it found.
What does that find button do?
You don't want to know. Like bad things. Okay. Don't hit the find button. All right, it found the process, so that's good, and we want it to attach. And in this UI, you want to pick the corresponding checkbox for which browser you're using. I'm using Edgeium, Edge Beta. It's awesome. You should use it.
I've been using it all the time lately.
And if that hopefully did the right thing, we should be good to go. Okay, so I'm going to go. Stuff's happening. It's like finding scripts. I'm going to go into my counter now. I'm going to hit a breakpoint, put a breakpoint in that counter increment count method, go back to the app, counter, click me, and boom. So there. We just hit a breakpoint in Visual Studio for code that's actually running in the browser on a WebAssembly-based .NET runtime. It's all speaking through the browser debugging protocol. And you can kind of tell, like if you look down here at the call stack, like you see JavaScript sprinkled in there. Like there's .NET and JavaScript stuff. And so if you're like doing JavaScript interop calls, you can actually like step from .NET code into JavaScript code and potentially back out into .NET code using this mechanism. That's why we're doing things this way. Now there's a bunch of limitations. Like there's limitations all over the place right now in the current implementation. So don't get too excited. Actually, let me hit that breakpoint again. I think I can hit it again. Yeah, good.
I'm sorry, but it looks like somebody hit the find button. And so, like, I'm responsible if the end of the world happens.
I hear screaming. Yeah. I hear children crying.
Sirens in the distance.
Limitations, like here, I'm looking in the locals. Like, I don't see any values here. I'm only seeing like typed and stuff. Like, this is stuff that we'll be working on over the course of the next few months to make this experience, again, as high fidelity, as close to a true .NET debugging experience as we can get it by the time we ship. But that's what you can play with now. So
there's a question here. I didn't totally get it, but Michael Powell's asking, could this be deployed as a debugging assembly, like along the lines of an XUnit runner assembly? I mean, this is all just in the browser, or I mean, this is all in Visual Studio debugging. Like, I mean, this isn't something.
Visual Studio is just acting as a client to the browser's debugging protocol.
Yeah.
And then we set up the browser to allow connections, and then the app actually exposes the debugging proxy endpoint, and so whatever the debugging client is, whether it's the browser DevTools or Visual Studio, it's connecting through that proxy to the browser to then enable it to debug. That's what's happening. You can also do it from Visual Studio Code if you want to debug. We can try that. Should we do that real quick? Let me open this in the command line, and let's get rid of all these hideous pixels. There's just too many pixels on the screen, like all these buttons and dials. And then we'll just open this up in Visual Studio Code. All right, so to make this work, I've installed the Debugger for Chrome extension, which enables debugging into a Chrome browser instance or a Chromium-based browser instance from Visual Studio Code. Okay. Here's my application. And now I need to get the app started. So I'm going to open up a new terminal. And I'm going to run the app by doing .NET run. And I'm going to run it with the debug configuration. So -C here means the config that you want to use for the build config. Yeah. And then let's go ahead and get that up and going. Okay, so we can see we're in the development environment, which is good because the debugging stuff's only wired up in development, and we're listening on 5001 and port 5000. Okay, now I want to debug. Let's go ahead and browse here instead of to this address. Let's browse to 5000. And hopefully that's working. Okay, that's working good. This browser instance was set up with remote debugging, so we should be all set there. Now I'm going to click on the debug little icon, and I'm going to add a configuration. And this will give me an option of selecting what type of launch profile I want to set up for debugging. I'm going to use Chrome. And then here, the magic values that you need to use for your launch profile. Type should be Chrome. That's right. Request is going to be attach. And then instead of URL, we're just going to specify a port. And we're going to replace this URL with the port that we are running our app on, which is port 5000. I think that's it. Let's see. So if we debug, hopefully this will say we've attached. Looks like stuff's happening in the output, so that's promising.
Wow,
Okay.
a lot of things were
A
happening.
lot of stuff happened. Good things. Only good things. Okay, so now if we go to our counter in Visual Studio Code, we set a breakpoint. We go back to here and we click. There, we just hit a breakpoint in Visual
What?
Studio Code. Okay,
Wow.
so this will be available also as as a cross-platform debugging experience.
Yep.
We're also working with the VS for Mac guys as well, so that you can have a debugging experience there
Excellent.
too. Okay, so that's the Blazor WebAssembly stuff. Try it out today. Try out 3.1, install it. I wanted to spend the last few minutes
Well, I one other WebAssembly question. So I cut
Yeah,
you off in mid, syllable.
I'm here for the community and questions. Like, go ahead.
So there's always, whenever we talk about WebAssembly, there's always to talk about how small can we get the download and optimizing the download and stuff. Anything new there?
So we haven't made a lot of progress on that front because we've been mostly focused on Blazor server.
Yeah.
There has been some progress, but it kind of goes up and down because we just added support for .NET Standard 2.1,
right.
so that adds features to the payload that you're bringing down, while at the same time we're trying to whittle away. So we're hovering right now around 2.2 megabytes compressed for the size of the application. Mm-hmm. Things that we are experimenting with. We are experimenting with linking more of the app. So right now when you build the app, we run the .NET IL linker on the core framework libraries to strip out any .NET IL that isn't actually being used by the app, at least as far as we can tell from static analysis. And that shrinks down the app quite a bit. But we only run the linker on part of the application. We don't run it on the whole thing. We don't run it on the Blazor assemblies or the entire graph of assemblies. So we've been experimenting with what if we linked more, and then we're more aggressive about the linking. We've also been looking at more aggressive compression. Instead of doing dynamic compression with Brotli, what if we just had a publish step where we compressed the thing to put it in instead of just having a little vise you got one of those big car crushing type of things in a junkyard. We played around with that. I mean the trade-off there is of course the amount of time that it takes to compress. Yeah. With those experiments, I think we've gotten down closer to a meg and a half for the application size. So there's some big wins to be had there. Other things we've been talking about is taking the DLLs and removing the PE header stuff from them because they're not really, that stuff's not really needed since you're going to be running in the browser anyway. That's an idea we've been toying with. There's still some things that we will be trying out as we get closer to the release. But that's about the range that we're at. Getting below a meg, I think at this point is going to be pretty tight. But getting under, I feel pretty good that we'll be under 2. Yeah. With Blazor WebAssembly, there's an inherent overhead with having to pull down a runtime with your application. And for some apps, if you care about every kilobyte of additional download size, then maybe this isn't going to be the model for you.
Well, as Scott Hunter pointed out recently, in that case, server-side Blazor is amazing because it's tiny front-end download, right?
The amazing thing about server-side Blazor server, is that it doesn't grow. You have the initial size, and that's it. You implement more code. Well, the code stays on the server. So you only need just enough to set up the pipe, and then that's as big as it's going to get.
Said 200K or something.
It's in the 400K range. Yeah, that's about what it is right now. But it's definitely pretty small, and it doesn't grow. Whereas Blazor WebAssembly apps will grow as you add more code.
So we're at 15 minutes left, and you have some crazy new exciting stuff. But one other thing I do want to point out: Blazor Mr. Magoo says he wants to have a fav icon in the Blazor templates.
Yes, me too. There's a bug. Everyone on the call should just go and +1 the favicon bug. No, don't do that. No, if you want to. But yes, no, we know about that. And I'm sorry that we have left that for so long. We will get that addressed for January. I commit that we will have a favicon in the template for January.
Okay.
All right, let's talk about some crazy stuff. So some of you may have heard of Steve Sanderson. Steve Sanderson is a dev on our team who is the father of Blazor. He wrote the first prototype. Does lots of great stuff. He wrote this blog post not that long ago, early in November, about this thing that he called Web Window. And what is Web Window? So we've been playing around with using Blazor for more than just web apps for a little while. Like we've been talking about this spectrum of applications that you could potentially think about building with Blazor. We've focused at the top where you're building a web app with Blazor Server and Blazor WebAssembly. But you can imagine moving towards a more native-like app. Like you could add PWA features, so your app works offline and it can be like pinned to your home screen on your phone, so it feels more like a native app. Still running in a browser though, fundamentally, but it feels more native. You could build imagine building a Blazor hybrid app where you're running natively on the device now, but you're still using web tech for your UI. And apps in this category are like Electron apps. Like Electron apps, they are native apps. They have access to the native capabilities of the device, but they're using an embedded Chromium shell for rendering their UI.
I mean, that's kind of like VS Code or
VS Code, Teams. There are a lot of apps that are built using the Electron model. Mobile apps have similar patterns, like if you want to render to a web view effectively, but you're still running natively on the device. And we've had like experiments out there with using Blazor plus Electron for a while. Well, Steve Sanderson had been thinking, well, Electron apps are great, but what everyone knows about Electron apps is they are a little heavy. I think the default Electron app weighs in at about 150 megabytes in terms of disk space size. It compresses down to like 60 or 70 megabytes or something like that, but just inherently.
And then usually about 6 gigabytes of memory usage.
I think the default app is 150 megabytes of memory usage just by default. And so I don't want to, Electron is great. Like it meets a whole bunch of scenarios. It has a whole bunch of really awesome features, but does beg the question, like, could you do something a little lighter? And lots of people have played around with this. What Steve played around with was, well, what if, first of all, you didn't include Node? Because Electron includes Node. And we have .NET Core, so we don't really need Node as part of this story.
Right. You don't need a whole web server thing going when you've already got it's already doing its own thing.
Yeah, we don't even need that extra JavaScript runtime. Like I'm going to be running .NET code, so I can just use .NET Core for that. And then for the UI rendering, well, most machines have probably some modern web view of some sort already on the machine. Couldn't you just use the one that's already there?
That was actually news to me. I didn't know that. I didn't realize that they actually had those as a control that you could use. So
I think a lot of this is also like you have a browser installed. That's the way to think about it. In fact, when I talked to Steve about this, he mentioned that you could even think of a model where, like, let's say you did want to ensure that a very particular version of a very particular browser was what you were using for your UI rendering with an app like this. You could have a check that looks on the machine and says, I require Edgium version 83 point whatever. And if it's not there, it would have a prompt that says like, hey, I need this version of Edge, please. I'm going to download and install it for you. Is that okay? And you click okay, and then it gets the browsers that it needs. So you can imagine doing that type of model, or you have a more flexible app that's like, I'm comfortable with anything that's like kind of new, and I can handle that. So Web Window is a simple little package that implements this idea. Like, I want to have some .NET code. I'm not going to have Node. I'm going to leverage whatever web view is already available on the machine and use that as a light way to build desktop applications. Okay, and the nice thing about this is you get some pretty nice wins. So he published these numbers. So this is comparing an Electron app with this web view model, in this case paired with a Blazor implementation. It doesn't actually have to be paired with Blazor. The technology that you use for actually rendering the UI could be anything you want. Like if you want to use Vue or Angular or whatever, like you can do that with Web Window. So if you're a JavaScript developer, this may also be something interesting to you. But the size, like the download size improvements are pretty phenomenal, and the memory size improvements are also like very drastic.
Yeah, that's crazy.
So if you want to get started with WebView, it's actually pretty easy. You just create a. I should make this. Here we go. I'm gonna go to my. Desktop, and okay, I don't have anything there already. So I'm just gonna create a console app. So .NET new console, and let's call it WebView app 1. Okay, and then we just need to add the WebView package. So I'm going to go into that console app. Go into that WebView folder, and I'm going to .NET add a package, web window, And I think it's web window. Is it web window or web windows? I'm gonna remember web window. Okay. And then the version, I think the latest version is 0.1.0. something. So I'm just gonna specify that. All right, so that adds the package that Steve published. And then let's go ahead and open this up in Visual Studio Code. So this is just a console app. There's nothing in here that's web window specific. And then there's a little bit of bootstrapping code that you need just to get the app up and going. So I'm going to grab that I've already copied that from his blog post, and I'll just put it in. We'll take a look at it real fast. Make this bigger. Okay, so we have a web window that we're creating, and it looks like I messed up my my indentation. Good. Okay, so we have a web window, and it looks like I need to add a using statement for web windows. Yep. And then in that window, we're putting some static HTML into that window, and then basically rendering it and waiting for it to exit. And that's it. That's the whole app. So let's drop to a terminal. And .NET run. Let that build. And here we have a native desktop app that's using the whatever browser I have on my machine for rendering its UI. And the UI is built using web technologies, but the code is implemented then with .NET, C# code. In this case, like in the other cases, if you wanted to use Vue or whatever, you could also do that. So that's the simplest like getting started experience. And I think we can look real fast to see how big is this guy, like how much memory is it actually using. So if I just look down here, what was the name of my app? It was like WebView1.exe. It's using about 5 megabytes of memory. So that's kind of nice. Oh, yeah. That's not bad. Okay, so we can close that. And then Steve has some nice samples on his GitHub repo that you can look at. So that's what I've got here.
While you're bringing that up, Janeski is asking if the default browser is different than what comes in the box, which browser does it use? So
I think it's intended to be policy. I don't know what the default policy is that it uses. It's, by the way, it's alpha experimental bit, so don't go like planning your next like mission critical desktop app based on this yet. So I don't know what its default policy is today, but the idea is that you as a developer should be able to say like, I require browsers with this kind of browser within this range. It will look for it, and if it's not there, give you an option that you can like actually download and install it. Okay. Now this sample is the same thing, a web window app, but paired with actual Blazor code now for rendering the UI. So if I run this, we got a web window app now with Blazor. So this is Blazor UI components. And again, very small, very lightweight. Like we can look at the size, but it's not much bigger. So that's web window. Definitely check it out, play with it. Let us know if you find this compelling, or because it's interesting questions now. Like, do we build a Blazor plus Electron thing? Do we try to build a lightweight thing like this? We kind of want to hear what people's scenarios are, so we can make those decisions.
So, like you're saying, this is alpha experiment that Steve's written, and you want people to give us feedback. Should we keep looking at it more? Does this look useful? All that kind of stuff.
Absolutely. All right, last demo. I got one more thing, and then we gotta finish up. Yeah. So the last bullet on this slide that we talk about, like this journey to native, is actually having a way to use native controls instead of using web tech. Well, what if we could actually use the native UI controls of the stack? Still using the Blazor component model, like this, the Razor syntax, bind and how event handling is done, all those things, but using UI, native UI control. So we've been playing around with that as well, and there's an experiment that we've been...
Havoc says we should call it blend forms.
It's not WinForm space because it's cross. It's not tied to the Windows UI stack. Like you tie it to some abstraction over native UI so that you can then use it cross-platform, kind of like React Native or even Xamarin Forms. Think of it that way. So I have this prototype installed, and I'm going to .NET new. What is it called? I think it's like mobile Blazor. I think is what we have it in this prototype, and we'll create mobile Blazor app. I don't remember how many I've created, so let's create number 2. Okay, and then let me cd into this folder. So you can see that we now have a solution with 3 projects. There's like a core project that has my components, and then a solution file, and then an Android host app and an iOS host app for this application. And let me open it up so you can just see it real quick. Let me go to my desktop and hold up 2. Good. Okay, and if we look in the core project, so this top project is referenced by the 2 platform-specific projects. We can see we have some Razor files here. We've got a counter and a hello world. If we look at counter, though, it doesn't look like it's not HTML. These are components that are wrappers around native components. In this case, well, it will depend on which platform you eventually run it on. If it's running on an Android device, it will use Android native components. If you're running on iOS, it will use iOS native components. So we've got things like frame and stack layout and button and label, but still a lot of normal Blazor-like things. Like we've got our code block, we have setting the text and so forth. So normal property element attribute style programming model, but done with native UI. If we set the Android app as the startup project, we should be able to get this running in the Android emulator. And this takes a second because, crossing VM boundaries.
Yeah.
But the idea here is that if you know Blazor, if you're, I'll say, a web developer and you've been working with Blazor to build web applications, you could then take a bunch of your know-how and use that now to build native mobile applications that have a full native UI look and feel. That's what this is intended to enable. Under the covers, it's for this runtime and for the abstractions over the components. It's using a lot of the Xamarin technologies to enable that. So there's a lot of synergies there. But it looks like it's building, and now it's deploying to the emulator. I'm sorry, I should have had the emulator up and running, but it's cold starting now. And we'll sit here and chat for a second while the emulator does its thing. There it goes. Again, this is part of that journey, and this is experimental code. We haven't even shared these bits publicly. This is something that we've been working on internally, but we're interested to hear from folks. Is this interesting? Is this idea of being able to build native apps with a Blazor component model useful? So here, now we've got native components. I can click on the increment count, and I basically have a Blazor counter, but implemented with native UI components on an Android device.
Okay, so I'm using the native, and like you said, it feels like you said, kind of similar to Xamarin as far as some of the markup, but it's using the component model from Blazor.
The markup right now looks a lot like Xamarin almost, because it is a fairly literal wrapping around a lot of the existing Xamarin Forms abstractions. Right, okay. But there's a lot of room to innovate there. You can imagine making it feel more, you make it more webby, more HTML-y if you'd like. I think Xamarin Forms, even at one point, they may even still have it, has support for styling the app using CSS. So you can imagine pairing a CSS styling system with native UI controls. Those things are all possible. It's an interesting question how much we dial that. My gut is that for a web developer audience, you kind of want to probably err on things that they know, things that they're familiar with. But we'd love to hear people's feedback on that. So this is kind of a native Blazor-like model that we're also working on.
Wow.
We'll hopefully have this for you to try out soon publicly. We're just kind of polishing it up and tweaking a few things before we share it out in the wild.
Well, from the chat replies, people's minds are blown and they like it.
Awesome.
Wow. Well, that's a lot we covered today. So we had the .NET Core 3.1, ASP.NET Core 3.1 release. You covered the stuff that shipped with Blazor server that shipped in an LTS, and then you showed the WebAssembly stuff that's in the works, and then you showed the crazy experiments both with the web window and then this latest using native components in a Blazor application.
Experimental mobile apps with Blazor,
Awesome. All right, and you had a 5 o'clock cutoff, and I think we squeezed as much awesomeness into that time frame as we could. So thanks a ton.
No problem. No problem. Thank you, and give us that feedback. We would love to hear what your experience is like with these bits.
So I think you should drop the mic at this point. Just pick it up and throw it down.
Apparently yours, because yours is the one that wasn't working. We can just throw it.
By the way, I think it's turned around backwards. I think.
If you just maybe.
I don't know. If I talk around the side, mic check. Okay, I'm going to end stream. Thanks a lot, everyone. Yay! Dramatic zoom out.